Polynomials. As we discussed in class 9, polynomial. What is a polynomial? Polynomial is a combination of constant and variable. Correct? Now, in 9th class, we discussed about factorization of polynomials. We discussed about zeros of a polynomial. Here also, we are going to discuss about the zeros of the polynomial. Clear? Now, what is a polynomial? Polynomial in 9th class, we discussed about linear polynomial, quadratic polynomial. Let us discuss about the standard form of a quadratic polynomial. This is the part of your syllabus. Your standard form of a quadratic polynomial, ax square plus bx plus c, where a is not equals to 0. Now what is this a? Where a is the coefficient of x square, b is the coefficient of x, and c is the constant term. Now, why do we call it quadratic polynomial? In 9th class, you have remembered we applied splitting the middle term, factorization. Right? There also, we factorize the standard form of a quadratic polynomial ax square. Can you see square? Variable is x, a, b, and c are treated as constant. So, x square, degree is 2, so it's 2. We say it is a quadratic polynomial. X power is 1. The highest power of the variable we call it degree. So that is what we call a quadratic polynomial. If you remember, in 9th class we had done this 2x square plus x plus 1. Do you remember? This is a standard quadratic polynomial. Ax square, where a is equals to 2, coefficient of x square. B is equals to coefficient of x, that is 1, and c is a constant. If I talk about another polynomial, say x square minus 3x minus 4. So here a is equals to coefficient of x square, nothing is there, that is it is 1. B, coefficient of x, that is minus 3, and constant is equals to minus 2. This is what you have done in class 9 also. Here also we are going to discuss on these form. Now, in linear equation, 9th class, you drew a graph. In linear equation, the linear equation comes from the word line, so it was a straight line. It was a straight line. Yes, same way, every quadratic polynomial is also having a graph. Every quadratic polynomial is also represented by a graph. On your textbook, page number 23. Where the graph of quadratic polynomial is given by a curve, and that curve is called parabola. Correct? And this is the shape of the parabola. You will be studying about the equation of parabola in class 11 if you take mathematics. It can be opening upwards, it can be opening downwards, we will be discussing that. It can be opening on the right side as well as on the left side. Your page number 23 of your NCERT book shows a curve. Please check your textbook, all of you must be having your textbook. Page number 23 is having a textbook, having a curve. In that you can see there is a table 3.1 and a curve is there. It is being carved out for you. It has been curved. Check it out. That curve is touching the x-axis at 2 points. Can you see that? It is touching the x-axis at 2 points. One of the points is minus 1, 0 and the other point is 4, 0, sorry. So that point is called the zero of the polynomial. By the curve, by the graph, we can identify the zero of this polynomial. Let me show it over here on the board for you. This is the curve that is there in your book. This is your x-axis, this is your y-axis, this is the point minus 1, 0, and this is the point 4, 0. So this curve is touching the x-axis at these 2 points. These 2 points are called the zeros of the polynomial. So therefore, zeros of polynomial are given by -1 and 4. And what is the equation of this polynomial given to you? It is given to you x square minus 3x minus 4. You can check the table. Correct? When we substitute the value of x as 0 over there, sorry, x as -2, the value of the polynomial is coming down to be 6. I am talking about this NCERT book that we follow. Right? The table 3.1 I am talking about. Next one, if I substitute x equals to -1, I can see the value of this polynomial is coming out to be 0. When we substitute -1 square is 1. -1 into -3, 4. Plus 3 and plus 3 and plus 1 plus 4 and -2 becomes 0. So this is the table. This is the curve. So every polynomial, quadratic polynomial, can be converted into an equation, and we can draw a curve, and this curve is called the parabola. Please check, there is a paragraph over there, second paragraph, you will find the zeros over there. Hello? Please check your net. Alright? So you can see that paragraph over there. You'll be able to identify the curves. One is opening upwards, the other one is opening downwards. And upwards and downwards depend on the value of a. Clear? When the curve is opening upwards, the value of a is greater than 0. When the curve is opening downwards, the value of a is less than 0. Alright, so that is there. Now you can turn your page and you can find several number of curves over there. Cases, case 1, case 2, case 3. Page number 24 and 25. Please observe those curves, you will be able to identify. The first 2 curves over there, they are opening touching the x-axis at 2 points. So how many zeros? 2 zeros. Second curve is opening upwards as well as downwards, but it is touching the x-axis at only 1 point. So it is having 1 zero. How come 1 zero, sir? Both the zeros are same. And in case 3, you will find that the curve is not touching the x-axis or the y-axis. So it does not have any zeros. So there are possible terms and you don't have any zeros. Now, how many zeros are there for a quadratic polynomial? We have discussed this in class 9. The number of zeros depend on the degree of the polynomial. How many zeros? 2 zeros. Why? The degree is 0. Sorry, degree is 2. If it is a linear polynomial, degree is 1. If there is a cubic polynomial, degree is 3. So there will be 3 zeros. We are talking about quadratic polynomial. So there are going to be 2 zeros always. Now those 2 zeros are given a specific name. If you remember, zeros of a polynomial are given by zeros of a quadratic polynomial are given by alpha and beta. These are the 2 new symbols that are going to be introduced. Now these 2 symbols are very, very important. There are a few more symbols that are going to be coming. Alpha and beta. There is a relation between the zeros and the coefficients. Which are the coefficients? A, B, C. There is relation between the zeros and the coefficients as well. What is the relation? That relation you have to learn. Relation between zeros and coefficients. What is the relation? First, sum of zeros. Sum of zeros means when we add these two. That is alpha plus beta is equals to minus coefficient of x upon coefficient of x square. So what is the coefficient of x? B, and coefficient of x square? A. So that means we can say that alpha plus beta, that is the sum of the zeros, is minus b upon a. First relation we have to learn or we have to remember. Second relation, product of zeros. Product of zeros, that is, we can say alpha into beta is equals to constant upon coefficient of x square. Therefore, we can say that alpha into beta is equals to c upon a. This is the relation between the zeros and the coefficient. Alright. Exercise 2.1. If you talk about in your NCERT book, it is all about graph. He does not want us to find out the zeros over here. He simply tells you find the number of zeros. How many zeros are there? If I talk about this, how many zeros were there? There were 2 zeros. Sir, why? Because it was touching the x-axis at 2 points. If the curve would have not been touching the x-axis, it was not having any zeros, as you can see in case 1, case 2, case 3, page number 24, 25. Alright, there are few more curves over there, and take a look at exercise 2.1. There are 6 curves provided to you, 6 lines provided to you, 6 graphs provided to you. He is not telling you what shape is it, what equation is it. He is simply stating the graphs of the y is equals to p of x, that is the polynomial, are given in the figure 2.10 below. For some polynomial p of x, find the number of zeros. How many zeros? Check the first curve. It is a line parallel to x-axis. Line parallel to x-axis. It is not touching x-axis anywhere. So how many zeros? No zero. It is a curve of a linear equation where there are no zeros. Second one, if I talk about, there is a curve. It is touching the x-axis at only 1 point. So how many zeros? 1 zero. Third one, 3 places it is intersecting the x-axis. Right? So how many zeros? 3 zeros. Again, he is not telling us to find the zeros. He is just simply telling us to number how many number of zeros are there. So please students, please check that carefully, and then we come down to 2.2. Please unmute your mics, those who have not. Please come down to exercise 2.2. That is the exercise that we have to matter. There are only 6 questions. 6 questions, but several number of questions I shall be providing you for your practice. Clear? There are several number of questions that we can do. So please check. We shall be discussing those. We will be provided with a worksheet also for this. Check those questions. It says, find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficient. Verify the relation between the zeros and the coefficient. So by this time, you should have been known what is A coefficient of x square, B coefficient of x, and C constant. What is the standard form of a quadratic polynomial? Ax square plus bx plus c. A coefficient of x square, B coefficient of x, and C constant. So please students, you be very precise ABC, because these ABCs are going to come again in linear equation. They are going to come again in quadratic equation chapter. They are going to come again in arithmetic progression also. All these 4 chapters of your algebra unit will have these ABCs. Now, let us discuss few questions from exercise 2.2. Check the first one. Hope you have not forgotten the splitting the middle term method for factorization. We have done several number of questions in class 9. Clear? Several number of questions in class 9. Again, we are coming down to that. It says first part, second part, third part, and sixth part are the same. I am talking about exercise 2.2. First question. Let us discuss about the third part. 6x square minus 3 and minus 7x. Okay. Now, is it the standard form? No. So why not? Standard form is right there in front of you, and this 6x square, then minus 3 is a constant, and coefficient of x comes over here. So we have to interchange the places. We are not transposing, we are just interchanging. So because we are interchanging, the signs do not change. So my standard form becomes 6x square minus 7x minus 3. Now can I compare it to the standard form? Ax square plus bx plus c. The only problem in case of plus, it is minus. So on comparing with ax square plus bx plus c, a is equals to 6, coefficient of x square, b is equals to minus 7, coefficient of x, and c is equals to minus 3. Clear? We have just compared it with the standard form. This was done in class 9 as well. Right. So here A, B, C is there with us. Now we can see he says factorize. Find the zeros. We know the relation between the zeros, right? We can verify. But first of all, we need to find the zeros. What are these zeros, Alpha and what do we mean? If you remember, we had done what does zero mean? Such a value of the variable when we substitute it, the polynomial becomes 0. The value of this polynomial becomes 0. That is what we mean by the zeros of the polynomial. Isn't it? So how do we do it? We apply splitting the middle term. We have done it in 8th class, we have done it in 9th class, we have to do it in 10th class again and again and again. So 6x square minus 7x, let us factorize it. 6x square minus 7x minus 3, those who have forgotten. On multiplication, we need product of the two extreme terms, plus into minus, minus 6x square into 3, 18x square. On multiplication, we need 18. So how do we get 18? Sir, 6 3s are 18, 9 2s are 18, 18 1s are 18. Right? These are the three terms. More are there in fractional form also, but we are going to take that. We are going to take the whole number. Now, out of these, which of them is going to give me 7, 9 and 2? If I subtract 9 and 2, will I get 7? Definitely. We need plus 7 or minus 7. We need minus 7. So sign of the greater number minus, smaller number plus. When I multiply both of them, minus into plus, minus 9 2s are 18, x into x, x square. When I add both of them, sign of the greater number, 9 minus 2, 7. So my factors are 6x square minus 9x plus 2x minus 3. This minus 7 is split into 2. Those who have seen, we have done this in class 9 as well. Check now. 6x square minus 9x, what is common? 3 2s are 6, 3 3s are 9. 3 and x is common. 3 2s are 6, 2 is left out. X square, x is common, x is taken. Minus 9, so minus 3 is left. 3x into 2x, 6x square. 3x into minus 3, 9x. Plus 2x and minus 3, 2 1s are 2, 3 1s are 3, nothing is common. 1 is a common factor. So plus 1 is common, what is left? 2x minus 3. Can you see both the brackets same? They will always be the same. So this is one term, this is another term. From both the terms, 2x minus 3 is common. So what is left? 2x minus 3 is common. What is left? 3x plus 1. So these are the two factors, not the zeros. These are the two factors. When we multiply these two factors, we will get this polynomial. That is what we did till class 9. Till this point we did in class 9. Now, from factorization, we will find the zeros. So how? To make this polynomial 0, we need to have the value of x such that this becomes 0. So what do? We'll find out the zeros. So therefore 2x minus 3 is equals to 0 and 3x plus 1 is also equals to 0. Solve it. Minus 3 comes over here, plus 3. So 2x is equals to 3. 2 is in multiplication, goes in division. X is equals to 3 by 2. From here, plus 1 comes over here. So 3x is equals to minus 1. 3 is in multiplication, goes in division. So x is equals to minus 1 by 3. These are the two zeros. You can verify. When we substitute the value of x 3 by 2 over here, the value will become 0. When we substitute minus 1 by 3 over here, then also the polynomial becomes 0. And we have a specific name. What is that specific name? Alpha and beta. So one of them can be alpha, the other one can be beta. So alpha can be 3 by 2, beta can be minus 1 by 3. Or beta can be 3 by 2, alpha can be minus 1 by 3. So alpha is equals to 3 by 2 and beta is equals to minus 1 by 3 are the two zeros of polynomial. These are the two zeros. These are the two zeros. Now we have to verify, so whether this relation is verified or not. Whether this relation is verified or not. We have the zeros. Now what is the relation? So alpha plus beta is equals to minus b upon a. We have the value of b and a. Alpha into beta is equals to c upon a. We have the value of c and a. Let us verify. Can we substitute and verify? We have the values of alpha, beta now. We have the values of a, b, c. Check it out. That is what he says. So let us check it out. I am raising this point over here. Correct? Please check. Please check. You will be able to see. Please check it carefully. So relate verification. Verification. First, alpha plus beta is equals to minus b upon a. Alpha, how much is alpha? 3 by 2. Plus beta, minus 1 by 3. Should be equals to minus b. How much is b? Minus 7. Upon a, how much is a? 6. So minus into minus plus 7 upon 6. Check it out. Open the bracket over here. 2 and 3. What is the LCM? Sir, 6 is the LCM. 2 goes in 6. 3 times. So 3 3s are 9. Plus into minus. Minus. 3 goes in 6. 2 times. 2 1s are 9 minus 2. 7 upon 6. 7 upon 6. Is it verified? Left hand side is equal to right hand side. Same way, second relation, alpha into beta is equals to c upon a. Alpha 3 by 2 into beta minus 1 by 6 is equals to c. How much is c? Minus 3 upon a 6. 3 into minus 3, 2 6 are 12. Correct? So what do I get over here? 3 1s are 3, 3 2s are 6, minus 1 by 2. And here 3 1s are 3, 3 4s are 12. Correct? That is a mistake. What is the mistake? Did we put some mistake over here? Beta was 1 by 3, not 1 by 6. 1 by 3. So this will be 2 3s are 6, 3 1s are 2. Therefore, what do we get? Minus 1 by 2 is equals to minus 1 by 2. Alright, please check it out. There are 4 parts over there, 6 parts over there. You can easily solve them. Alright, please try it out. Then we shall be discussing your problems. Thank you.